First of all, Happy New Year, everyone, and best wishes for 2024.
No, solamente te digo el pozo este de torneado. Es lo único que tenemos, pero bueno, tenemos pendiente que conseguir.
Can you just mute? Thank you. So I'm very excited to start this new year with the third conference of our series at INPC. So today, our speaker is Maxime Gueguin. He holds a doctorate in structural mechanics and materials. His work mainly focuses on industrial asset management through a fusion of statistical and physical models. As delegate scientific lead of Eurobios Mews Labs, Maxime manages different partnerships and has written numerous scientific publications on these topics. Today's lecture is about optimized industrial asset management by monitoring data for predictive maintenance, showing the synergy between statistical methods and numerical simulation. So like you know the drill, like all times, Maxime is going to talk about 40 minutes, maybe 35, 40 minutes, and we will have question and answer at the end, like always. So you can raise your hand on the Teams feature, and if you want to ask a question at the end. Maxime, the floor is yours for your lecture, and thank you for joining us today at the NPC.
Yeah. Thank you, Matthew. So yeah, today I will talk about my work as a research R&D engineer at Eurobios. First, I will talk about what Eurobios Mews Labs is. Then a short speech about RTE, which is a French transmission system operator. It will be my use case for today. The main part of my presentation will be on
Maxime, I think you're on mute.
Yeah, sorry, can you hear me?
Yes, we do.
Okay, yes. Sorry. So yes, just step back on what I will present today. So I will talk about RTE. It's my use case, but our approach is not dedicated to this transmission system operator in France. It can work on every type of, let's say, linear network, if you want to. So I was trying to say that we are a part of a management consulting firm, which is called Mews Partners. It's a French company. It's around 280 employees now. And we are working on every step of your product, from innovation to supply chain. And we also have some offers dedicated to specific offer. On the one I'm working at is dedicated to data and modeling, and I will try to explain to you what we are doing. We are working with industrial sectors, as you can see, mainly on aeronautics, because Mews Partners was created in Toulouse, working with Airbus, but now we are working also in Paris with every type of companies, and RTE is one of them. What I'm doing in Mews Labs, we are a part of Mews Partners, and we have more engineers dedicated to technical developments. So we are merging the expertise, the business expertise of Mews Partners, which is a consulting firm, and we are using in Mews Labs, let's say, numerical tools to help for our use cases here, to help asset manager in their decision on the network. So we have mainly PhD engineers with PhD at Mews Labs, dedicated to applied mathematics and let's say all physical parts of a system. Some of them are more working on structural analysis and mechanical analysis, but we also work on other topics. And one of the things that is specific to Mews Labs is we are working with research centers, such as Laboratoire Navier in École des Ponts, when we need to have specific expertise and scientific expertise on the projects that we are leading with industrial companies. So to be more specific on the speech for today, I will just present what is RTE, which is not really known even in France. So it's a French system operator. And what does it mean? So RTE is the largest in Europe TSO, so transmission system operator, and it's the only one in France. And when you are a TSO, you have two main roles. You need to ensure the power delivery to electricity distributors such as Enedis in France. So when you are at home, you are using RTE infrastructure, even if you don't know the name. And when you are a TSO, you need to balance the power delivery, but you also need to manage and develop your network. And here it's mainly high and extra high voltage, which is between 45 kilovolts and 400 kilovolts. In France, we have 100,000 kilometers of lines. I will explain what it means, but it's specific in France. We only have one TSO, so it's a large network. For example, SNCF. We are also working with SNCF. They have 30,000 kilometers of lines. So it's huge. RTE is dealing with a huge network. I will not give more explanation on the asset, but just a few words about it. So Eurobios Mews Labs is working with RTE since 2016. So we know the network, and we also know the assets composing the network. So we are working on overhead lines. It means everything that you see from the ground to the top of a pylon. But it seems like a simple asset and a simple system, but it's not that simple. As you can imagine, you have challenges with high heterogeneity of the components because you have these pylons. It's maybe 40 meters tall. The distance between two pylons is around, let's say, 500 meters. But the cable, which is ensuring the power delivery, is composing by a few strands, which are, let's say, few millimeters large. So it's really heterogeneous. And it's one of the things that we are working on with RTE. And the other thing is because you have this network which is dealing with environmental and climatic condition, you have complex physical phenomena such as mainly the electric current, but you also have the wind, the snow, the sun, and it changes your system every step, every time. So it's really not that simple, and that's the reason why RTE is keen to work on this topic. The other thing to know about RTE is there is an asset management policy, which is, let's say, was imagine after the Second World War, and because you have 40 kilometers of cable, so you have 400,000 kilometers of cables. You have 3 phases. Sometimes you have many cables for one phase of your electric system. So you have a huge amount of cable on your network, and it's the main challenge for RTE is to imagine how to refurbish the network concerning especially this overhead lines conductors. So the current policy of refurbishment relies on diagnosis. So you need to put some non-destructive tests on your network to make sure that it's still good. You also use maintenance history because maybe you add some defaults and you need to change part with too many faults. And also the age of the system is important. But as you can see on the figure here, because the network was mainly developed, let's say, between the Second World War, and in France we have nuclear plants since 1960, 65. We have a large part of the network which was developed during this period. So it's a gray area that you can, not on this, but maybe on your screen, you have this area which is the first problem for RTE. And after this, when France developed more nuclear plants, you have a second peak for your refurbishment. So here we are around, let's say, you replace your conductor after 85 years, in theory. So we are here, it's okay. But in few years, maybe 10 to 20 years, we will have the first peak, and after this, the second peak. So you need to imagine another way to do your refurbishment of your network. And that's the reason why RTE initiated several R&D projects, and one of them with Eurobios Mews Labs. So it was the topic, and I wasn't supposed to speak more than 5 minutes about this, but it's really important to understand what we are doing with RTE. As you can imagine, this kind of network, you have many types of digital twins for this network. Obviously, because you are dealing with power delivery, you have a digital twin, natural digital twin for RTE, which is can I use this part of the network, and how many electric power will go through this part of the network. So it's one digital twin, but for asset management and, let's say, physical asset management, it's not the one that you want to develop. So I will try to talk about this thing during my speech. First, if you imagine what you are doing with asset management, when you have an asset, you have several phases, several reasons for failure for an asset. So at early ages, in red here, you have the installation defects because it wasn't done properly, because maybe it wasn't in a good the good day to do the job. You will have some defects at early ages. After this, you will have maybe design issue because you have the right system, but not in the right place. And you may suffer to, let's say, for example, for overhead lines conductors, it's the vibration of your cable. So you can do something to protect your asset, but as a first place, you didn't think to use this. All around your let's say the life of the asset, you will have extreme events, failure due to extreme events. It's bad luck, obviously. You may have, let's say, a tornado. You can't do anything about this, but it's life. What I've done here, it's let's say that during, I don't know, 100 of years, we had mostly the same failure rate due to extreme events. Now, because due to climatic changes, obviously something will happen. I'm not sure what. I'm not sure if we will have more tornado in the north of France. I'm not an expert about this, but obviously you will have more extreme events due to this kind of thing. So it's the reason why this curve is going up. But at the first place, it's supposed to be the same failure rate all over the time. And what we are working on with RTE is aging. So it's at the end of the day, everything has an end, and you want to simulate and to make sure what will be your changes, your need to change, and your, let's say, lifespan for your assets. It's the 4 steps, 4 phases during life for an asset. So we were working on this, but because we tried to work on this, we work on also on every phases with RTE. So I was really happy to hear about this master when Jérémy and Mathieu told me about this, because to make a digital twin for infrastructure, for me, I'm not sure I'm doing digital twins, but what I'm sure, it's really complicated to try to do so. So our story with RTE, we try to simulate what will happen during aging phases of your assets. So you are in 2016 when we started, and you want to know which part of your network you will need to change in 40, 50, 100 years. So to do so, you may say, I will use only data, because I'm from the physical part of the world. I'm not an expert in data. At the first place, I wasn't. And you can't imagine to use only data to do this kind of forecasting, because it's data, let's say, machine learning is not that good to extrapolate. It's really good to interpolate, but it's not that good to extrapolate. So if you want to extrapolate, and that we are trying to do, because we are trying to imagine how some of the assets now with node effects will age, we need to use some physical modeling. So we started with this. I have a slide about this. When you start to work on this, and you are, as we are, an R&D team, you first work on, let's say, perfect data. And one day you need to work on every part of the network, and you need to deal with real database and industrial database with lots of, let's say, lots of work to do to clean this. But in what you can imagine is you want to know what happened during the life of each asset of your network. It's not that simple, and you need to have some data engineers to connect physical modeling and databases. And because we were working on this, as I said, you may be interested to work with the initial data, the data acquisition, which says how my asset is, in which health my asset is right now. So in Eurobios Mews Labs, we are not developing a solution to do some non-destructive tests, but we want to use the raw data of this kind of tests to forecast what will be the defects on the network in the future. So we work on every step of this. And as I said, it's really it's not that simple to work on this kind of data. So you imagine the first path, it was a perfect path, but after this, you need to first make sure that your data are good. And you may deal with missing data. So you want to consolidate what you have on your network. Be sure it's what the database is saying. So I will have a few words about this. Once again, the quality check for every database is important, but when you are dealing with assets which were, some of them were built during just after the First World War, you deal with data quality, and you may want to improve this data quality. And we were first R&D project working more on physical modeling and forecasting. But one day, because we have done all these steps, we were identified in RTE as a data provider, let's say, clean data provider. And we try to put everything that is important to make sure that if one day you are querying specific data, the day after you will have the same data, or if it's not the same, you know why it changes. So it's what you can say continuous integration and continuous deployment approach for this. And at the end of the day, because forecasting simulation is quite difficult for to understand for asset managers, you may want to deploy some dashboards, which is a good way to improve the decision making on a network. So just few words about this. Yeah, I still have the time. So I have one slide for every step. I will make sure that I'm in the good. I will try to make sure that everything is clear. First, when you are working with non-destructive tests, for example, you will have some service providers. That's the choice of RTE. They don't do the job for non-destructive tests. They hired some service providers, few of them, to do so. So what the service provider will give you is, let's say, where the measure was taken, the raw signal, maybe some pictures, maybe some report. And if you want to use this for your, let's say, your digital twin, you will have several types of data. So you want to make sure that you have something which is relevant, and you will find the data whenever you want. And for this, you may use some structured database. If there is some pictures, some contextual data, you will put this in another part of your cloud. But if you want to make sure that every service provider is giving you what you want, you will need to work on the standards. So the format of what you want, the naming, the definition of what the measurements are supposed to be. And after this, you can do some, let's say, health monitoring. Meaning that you will know at every non-destructive test, you know where and why it was taken and what your decision is supposed to be. Data consolidation is important because I think it's a part of the capstone project that we are proposing. So we worked, and it was not the main part of our project, but we worked on the fact that because the database is not may have some missing data, for example, like let's say the pylon, the type of the pylon. you will use some external data, something that you can see. For this, you can use, for example, the leader, some leader point clouds. So I think Altametrics is more expert about this than me, but RTE has something to do this, and we worked on the segmentation of this, because when you are dealing with networking with point clouds, you want to make sure that you will automatically detect your asset on one stage of your captation, and it's specific to every asset manager. When you are dealing with TSO, you want to make sure that you see the isolator, the pylon, the cable, and this kind of thing. And after this, you may say you have, for me, it's one type of digital twin, but you are using this to do some mechanical calculation and simulation, and that's what we try to do with RTE. But during the capstone, we will have the opportunity to work more about this. And the other things that we are using to, let's say, consolidate the patrimonial data is a satellite, and using Earth observation to make sure that the pylon is here and it's this kind of pylon. So it's really, I think, something important in our project, but not the core of what we were doing. Maybe for databases and data quality and CI/CD, it will be shorter. But one thing that you learn, I think, during the master is how to build a data model. So to think about data model, you need to think what will be the use cases of this data model. So here we wanted to make the link between a pylon, a cable, what is connected to the cable, and it's the definition of the entity relationship model that you will build. And after this, you have some tools to as you can see on this part of the slide, you will have the opportunity to you have some tools to click and see at this point of the network, I have this type of pylons. I can see if I'm in a field or not. I can have something related to OpenStreetMap and this kind of thing. It's important for a data manager, not that important when you are doing mechanical simulation, because you want to work and to predict what will happen on every part of the network. But when you are dealing with specific part of the network, this kind of tool is really important. As I said, because you have some use cases, your data quality is important at some point of your database, but not everywhere. So what we try to do with RTE is we organized some workshop with subject matter experts, and we asked them which kind of data was important and which requirements they could give to every type of data. So for example, you know that a pylon can't be more than 60 meter tall in France. But in your database, you see that some of them are 1 kilometer tall. So it's this kind of thing that you see when you are dealing with real industrial data, and you want to avoid this kind of thing. So every year you check if the quality is good or not. Where it's not good, you try to work on this and to correct your databases and so on. And it's really important to do so. But sometimes in some companies, we have seen that they try to do this, but there is no goal, no real application of the data. So here we worked with RTE to make sure that we are working on the data quality only on the part of the databases which is important for our work, and maybe sometimes it's not important. It's not that bad to have poor data quality on something that nobody is using. So it's important to do this kind of thing. At the end of the day, when you want to, it's related to the first point, but when you want to deploy data-based application, you want to make sure that if you are working with another version of your database, every application will work, and you have no bug in this. So you may use something that software developers are doing since decades, is unit tests and so on, to make sure that before you are deploying your database, you will not have a bug in any applications that you have. But it means that you are working with the end users and the people that are developing application. So luckily with RTE, we are doing both. We are working on database and on application, but sometimes you will have an application that you don't know, but you only know that they want to work with your database, and you need to make sure that they have done. They told you what will be the unit test for them. So it's really a work. Well, as I said, for software engineering, it's known since decades. I was lying for my title. It wasn't that good. I won't talk that much about physical modeling, but it's the only slide on it, almost in this slide. What we are doing with RTE is, because we are working on asset aging, we identified with them the main aging phenomenon, such as fatigue for the cable conductors. And when you deal with fatigue, as I said, it's really heterogeneous. So you need to do the vibration of your cable. So here it's obviously not the real. It's just to make sure that you can see something, because it's not that much. The cable is interact with the air, so you will do some computational fluid dynamics. You can simplify this. You have the 3D model, but you can have some strip around all along your cable to make sure that you have the right vibration for your cable. And after this, you put this in the physical structural mechanical software, and you will have the fatigue of your cable. So it's really something that we deploy with RTE. We have open tools. We are maybe it's not ready yet, but in few days you will have on RTE's GitHub. You will have some of the bricks that you can see here for free. It's an open code, and I think we will use this for the capstone project. But yeah, physics is important because, as I said, maybe you will endure some new type of wind in France, or you will have new condition that you haven't seen on your network, and you can't rely only on data to predict the effect. Dashboarding for me is really important because it's what you put at the end of the day. For your decision, you will need to have some dashboards, but I'm not sure it's the main purpose of the conference and of the master. You have some technology such as Power BI or ClickSense to do so. It's really important to connect this to your database. Really important to do unit tests to make sure that you won't have anything to say on your dashboard with weird data. But yeah, for me, it's one way to take the decision in here. we are trying to work on other part of the purpose. For forecasting, we had two parts. First one is related to refurbishment. Which part of the network I will need to change in the next decades? So we used observation. So you have some faults on your network. Some strands of the cable are broken. Believe me, it's what you see here. You have patrimonial data. I'll talk about this. How tall is my pylon? Which type of cable I have? This kind of thing. And you have environmental data. So you use weather data. For example, the wind speed. In France, in Europe, we are lucky because you may have this kind of data since 1960 to 5 days ago. So it's every hour you have. I think it's a 30-kilometer grid. You will have which wind speed was supposed to be at this point. It's a model, but it's connected to real measurements, so it's not that far from the reality. And you use some machine learning algorithm to predict which defaults you will have using these features. Here it's a classification problem, but sometimes it's a regression problem. For us, what we want to do is mostly to say this asset is at risk on your network, and maybe you will need to change it before the other one. So it's more a classification problem, let's say, a scoring problem at least. We are not saying that this kind of asset will have a failure in 10 years. That's the first part. The second part is what I was saying lastly, remaining life. It's really changing. You have some really powerful algorithm to try to do so, but most of the time you will need to have many defaults data. So it works on some parts, some assets of the network with RTO. Some others it doesn't work because we don't have the data. And here, in that case, we are lucky and we are really happy to have the physical modeling to try to do this. The last slide on this topic, and after this it will be good, is when you have your digital twin, you may want to do some extreme event climatic simulation. You don't have the data because there were nothing happened on the network like this, but you want to know what is the risk, what will happen if I have a tornado or something like this. So that's what we are working on currently with RTE, but we try to do some calculations. So you may say here it's another type of digital twin of your network. When you are a mechanical engineer, that's the kind of thing that you want to do. And because we have this new extreme climatic condition in France and everywhere around the world, it's important to have this kind of thing. So just two slides. The first one is what I presented today is what we call the hybrid modeling at Eurobios Mews Labs. It works, so it's, once again, it combines physical modeling and statistical learning. I tried to explain more in details during my presentation, but you will always have the data acquisition, the physical modeling. Maybe you may want to use some machine learning here to speed up your numerical simulation. And because you have the powerful tools of statistical modeling, you can combine them to help to decision. And we work on this with SNCF also to work on fatigue events railway rails since 2018. So it's also a large project for us, and I will be happy to explain this maybe in Madrid or so on. So yeah, just one last slide. It's really not, it's a draft, but what we want to do for the capstone project is to push further our approach. So here we only worked with RTE database. We want to work with free open database that we have in France for LIDAR, for maybe also other type of data that you have for the network. And we also want to work on the Earth observation and satellite image because we didn't have the opportunity to push that much this kind of thing, but we had a few projects on this. So using this kind of images to do the classification of the pylon and to try to have the 3D geometry. So in 2024, we want to work on this, and I think the capstone project is a good opportunity to work on this. And after this, we want to make sure that the cable during, let's say, windy days, you won't be too much closer to the trees and things like this. But I think you have the same kind of issue for the railway and the trees and altimetries. Once again, maybe work on this. So thank you. And if you have some questions, sorry, maybe it was too long. But
Just thank you very much, Maxime, for this wide map of your digital twins at Eurobios. I think it was very relevant for the master because you mentioned a lot of different bricks, mainly a lot of bad data, but also about machine learning and simulation, and these are exactly the different courses they have in the master. So that makes sense to put them together. And thank you to mention the capstone project. I forgot to mention it, but we will communicate more generally about that to the master students during January. For the last minutes, if anyone has a question, so in the same in the classroom, and just a quick click on the raise hand on the Teams button, or you can just open your microphone if you want. So we just have one question here. So go on, Juan.
Hello. Yeah.
Hello, Juan.
So my question is, Maxime, you said that you complete the data that you don't have in the in the data model with the physical model, no? So I imagine that when you perform a physical model, the physical model usually spend a lot of time to be run. So you usually have only a small amount of results. So how do you deal with that in order to, for example, to perform the remain life of the asset? Because that kind of analysis requires a lot of data to be done. So do you perform only a reduced number of physical models and then do a parametric analysis, or how do you deal with that in order to do it in a, I don't know, in a good way?
Yeah, it's a really a relevant question. I didn't talk about this that much, but yeah, obviously, as you said, when you are dealing with, let's say, cable vibration, if you want to do a 2-hour simulation for real time, it will take maybe 30 minutes, something like this. So you can do this for 80 years and for all the French network. So what you want to do is to build a database with physical results, with your physical modeling, where you explored every part of your features. So it's really a design of experiment methodology that you want to do. Once you have done this, so for example, you have cable lengths between 100 meters and 1 kilometers. You have, let's say, I don't know, the weight of the speed, the wind speed, something like this. So you will do. It's not a grid, but you will do something to explore every part of your let's say parameters space. And after this, you will have a database. When you have this kind of database, you can do what we call surrogate modeling, something like this. You will do some statistical regression to predict what is the results between the point of your initial grid. So it's not a good idea to do a grid. When you are a physical scientist, you do this, but it's not a good idea for statistical modeling. But yeah, it's what we call surrogate modeling. When you do this, I'm sorry, it won't be really good for the video, but that's what I was trying to show here. When you are working here, you have 1 second to do the vehicle track interaction for railways, and you have finite element model. It's 5 hours here, so you have many. Yeah, you can't do anything you want. You have few points, but once you have this, you may learn on this kind of database I was talking about. And after this, when you want to predict, you want to do some inference or to do some fit if you are working with scikit-learn, it's almost costless. It's not that that heavy to run for every part of your network. So obviously you need to be clever. Obviously you won't do physical modeling for everything on your network, but if you do some physical modeling, everything is everywhere. It's important in your parameter space, hyperspace. You can do some surrogate modeling after this. So that's what we do every day at Eurobios Mews Labs, because yeah, when you are working with SNCF or RTE, you need to do something like this. But yeah, it's you do, as you said, you do only on few kind of thing, even if it's not a real case, real asset on your network. And after this, you have a clever approach to make sure that you will do some good enough approximation of your physical modeling.
Thank you.
Do we have another question, maybe? Here in the room.
When you think about building a digital twin in general, what would you say that are the steps to build one? Would you go from the need of the operator? Would you target some other specific things? I don't know.
Yeah, it's a good question, but here I'm not. Once again, I'm not the expert. What we have seen is every time we try to do a project with industrial companies, you need to, as you said, you need to know what is the final use of your work. And for digital twin, for me, it's the same, because as I said, for RTE network, you have several types of digital twins. Here, we wanted to have the aging of the network. So it was the end point. And after this, we built the digital twin from this. I'm not sure it's the only way to do so, but for me, it's one way to do so. The problem is when you have several and too many use case, and you want to have few digital twins. How do you do this? I'm not sure. Maybe you need to to have something more generic than what we have done. But yeah, it's really a good question. We are not dealing with BIM here in this project.
Yeah.
We want to work on this kind of infrastructures. What do you do with BIM model? It wasn't made to do some physical modeling. I don't know now. We are working with some companies on this, but it's not exactly the same problem than RTF. So BIM wasn't made for this. So we will need to be smart, but maybe because you have something like standards for format and things like this, it will help. Here we started from scratch, so we have done what we wanted to do. But yeah, we worked on thermal modeling using BIM. It works. You can do something. It's interesting. Mechanical and aging phenomena, we didn't do this for the moment. So another challenges.
Yeah, if I can just maybe a naive question, I was wondering because you talked about 400,000 kilometers of lines,
yeah,
which is very huge, and you want to assess the aging of the system or of this network. And one of the examples you talk about observation, mainly human observation, I think.
Yeah.
But I was just wondering the frequency of to go along all the 400,000 kilometers, but with human people, just to take pictures. It's very huge.
It's one main role of RTE every year.
They do that every year?
Each part of the network is supposed to be seen every year, but by someone from RTE.
Okay.
Some of parts are seen more frequently than every year. But yeah, every year. So it's almost the only thing that RTE is doing itself. It's maintenance and observation of the network.
Once they finish to observe the network, they have to start again, actually.
Yeah. Exactly.
Okay, thank you. Maybe a last question, if you have. We do have another one in the classroom, so maybe we can. Is it USB? No, it's not.
Can speak louder.
Louder, yeah.
Yeah, another question was in this project for RTE, what would you say was the task the most critical to build this digital twin? Was the hardest or the critical?
For us, we have the physical modeling, which is a challenge, but we had all the things that we need to have to do the work. The more challenges, what was the more important is to be connected to a database, real database of RTE, and to work with, understand this database. It wasn't made to do asset management. And to connect this, to make sure that you have good data quality and things like this, it's really a challenge. Even today, it's an everyday challenge. So it's really important, this kind of thing. Otherwise, you have only a static view of your network. And here we wanted to have something which is more like a movie. So yeah, that's why it was in green and center of my slide. It's really a challenge. Not huge for every task, but you need to do this again and again and again.
Okay. If we don't have another question, I think it's 2 p.m. so we can close the session for today. Thanks again, Maxime, for coming from Eurobios. So for the remote attendance today, you will see his face again for the capstone and the event in Madrid in February. So thanks again, and stay tuned, as we say, for the next conference in 2 weeks, I think, Jeremy, something like that, at the end of January. which will take place at 2 p.m. Thanks again. Have a nice day, everyone. Bye, everyone.
Thank you. Bye bye.
Thank you.